Hi, my name is Jared Michael, and I'm a demo artist working for Intraware Australia, supporting Foundry Products. In this video, we're going to take a look at the new features and enhancements made to the Foundry's Nuke 10. In this presentation, I'll first talk about where Nuke has been, where it currently is at, and future plans. I will also talk about Nuke Studio and recap the features, before I move on to Nuke 10 and talk about the enhancements and new features that have been added. Finally, after talking about this, we're going to jump into a live demo and see some of these features in action. The previous version of Nuke, Nuke 9, was a response from the community asking for further reliability and stability. The response from the Foundry was to rewrite a number of core areas under the hood to address these performance issues. In addition to this, Nuke Studio was launched, allowing a single software package to manage a variety of tasks from compositing, managing compositing at a timeline level, editing, conforming, and finishing. The response from Nuke 9 from the community was a request for more refinement, reliability, and performance across all areas. And whilst addressing these concerns, a number of time-saving new features were also added to the release of Nuke 10. Before we talk about Nuke 10 and the changes made to Nuke and Nuke Studio, I'm just going to take a minute to recap what Nuke Studio is for those of you who haven't used it. In effect, it is a node-based VFX finishing suite. It allows you to conform, edit, grade, playback in real time, but it also contains all of the functionality of NukeX, whilst also allowing compositing to be managed at a timeline level. Nuke Studio is effectively a hybrid between Hero and NukeX, providing a timeline environment with standard editing functions that you're familiar with from other packages such as Razor, Slip, Slide, etc. It has the standard Nuke viewer that allows you to A, B, stack, wipe. It has track blending that respects alpha embedded in a channel, as well as the ability to very intelligently cache depending on the direction you are playing to provide real-time playback, whilst having the same localization system that is in Nuke and NukeX. Nuke Studio has a robust conforming system that allows you the flexibility to either fully edit in Nuke Studio or for you to import from another editing package using an EDL, XML, AAF. You can import an offline as a reference layer so you can check that everything is lining up before conforming to your full online footage using the match media function. This allows you to specify a general folder or location on your network to search for the raw files, and you can also exclude file types from being searched for. One of the most powerful features of Nuke Studio is the ability to create comp containers, represented here in the top right image, a series of green shots. This allows you to double-click and enter and exit a Nuke script very quickly and easily. The intelligent background rendering allows you to hit render and allow that process to go in the background without stopping you from working. A progress bar lets you know the status of the render, and you can preview this wherever that render is up to. Nuke 10 has excellent collaboration tools, such as the tagging system that allows work to be allocated, the status of each shot to be marked, such as ready to begin, complete, or requiring a certain type of work, such as green screen, or marking it for a particular artist. And all of these tags can be customized with Python. The annotation system, seen here in the bottom right, allows artists to be briefed visually, as well as to provide feedback on things to change. One of the most powerful features of Nuke Studio is the export structures. This allows folder hierarchy to be set up for an entire project, as well as naming conventions for folders, Nuke scripts, and the output of all type of files. Beyond this, the export structures window can be used to transcode footage. For example, if you have full onlines which are i3D and need to be converted to DPX format, these can all be exported out and then loaded back in, replacing the old R3Ds using the export tag which is generated on export. All of these features will render locally or on a frame server. There are also a number of time-saving tools, such as the ability to sequentially rename shots based on their order in the timeline, as well as the ability to copy cuts across all tracks on the timeline. Now let's move on to talk about Nuke 10. The focus has been on performance, feature improvements, and bug fixes across a few key areas. Through feedback with the community, there were a number of workflow fixes. RotoPaint was one of the nodes identified for a number of bug fixes, and across the Nuke Studio range, the UI stability has gone up dramatically, as well as playback performance on the timeline, the ability to handle large projects, and the speed and stability of transcoding and exporting. Further enhancements to Nuke Studio include refined editorial and conform tools, such as audio scrubbing, as well as a series of new soft effects. Specifically, color correct was added, where in the past only the grade node was accessible on the timeline, opening up the opportunities for further creative color correction. Another new soft effect added to Nuke Studio is a blink script node. This allows GPU accelerated nodes to be written specifically for working on the Nuke Studio timeline. An example of this is the new chroma key soft effect. This is a blink script created node written to work in real time whilst keying on the timeline. This is perfect for rapid look development so that the background can be inserted quickly, potentially with a client there, to get approval before the final compositing happens in the node graph. This opens up opportunities for either the community or for third-party developers to come in and write more GPU-accelerated real-time soft effects to enhance the capabilities of Nuke Studio. A brand new feature of Nuke 10 is the Ray Render node. This is a true ray trace renderer with scanline output. It is effectively a replacement for the old scanline renderer in almost all circumstances. It has a lower memory footprint, allowing for more complex scenes with higher fidelity output. This new node offers higher quality motion blur and shadows, and at the same time now has a really nice reflection render as well as ambient occlusion, as well as being faster at processing spherical projection. On top of all of this, it has improved supersampling, resulting in better anti-aliasing. To be clear, this is not a standalone renderer such as V-Ray for Nuke, where you could do all of your traditional shaders, lighting, and rendering. The purpose of this is more to create a few additional passes, where in the past you might have to go back to the 3D department. Comp now has the ability to create better ambient occlusion and better reflection for pushing the image slightly further. This would definitely be useful in areas such as matte painting, where ambient occlusion in a 2.5D set extension may be required, as well as reflections, for example, the windows of a city building. The localization system in Nuke, NukeX and Nuke Studio has also been revised. This is now uniform between the applications, and it is executable as a background process, only using some of your cores, so as to not stop you working. The new localization system allows you to pause, refresh, or force direct sourcing from the network of your footage, as well as giving you a progress bar informing you of the status of the localization. In Nuke 10, the RotoPaint has had quite an overhaul, starting with a number of bug fixes which have been logged in the latest release notes. This is quite comprehensive and goes quite a long time back in terms of bug fixes and workflow problems. In addition to this, the number of strokes that is possible per node before having any sort of delay or slowdown performance has been dramatically increased. In the past, around 200 strokes per node was the upper limit before having to split into multiple RotoPaint nodes to avoid delays or performance issues. Now, it's possible to have a very large number of strokes per node without having any performance issues. In addition to this, during regular RotoPaint, the response time between clicking and putting a stroke down has been improved, offering a more interactive experience. One of the new features in Nuke 10 is the Smart Paint toolset. This analyzes the motion in a plate to generate a new type of vector. With this, paint patches can be deformed across a surface to match the original animation in the plate. The bottom right image is an example of the Smart Paint toolset being used. The shirt blowing in the wind creates quite complex motion, and to manually warp this by hand with spline warp or other technique would require quite a long period of time for the artist. With the Smart Paint toolset, vectors can be generated of the original VOR plate and then used to deform a single frame, deforming the paint patch across a surface, requiring no further manual work. Beyond all of these improvements, there are also a number of other enhancements and additions to Nuke 10. There is a new vector blur algorithm called Vector Blur 2, which is now GPU accelerated, delivering a noticeable increase in performance in the node graph. There have been a number of improvements to the color pipeline tools, including the integration of ACEs as well as OpenColor I/O. Performance increases to the transcoding system mean that now writing out media, such as DPX, EXR, and QuickTime files, is now faster, taking less time to write out dailies, artist review, the final output, or simply transcoding from one format to another. There is now more support for a broader range of different GPUs, including AMD for MacBook Pros, and now there is support for use of multiple GPUs in one computer. As a response from clients asking for clarification about hardware requirements, the Foundry now includes hardware requirements and recommended suggestions for hardware in all of the new release notes for each software package. In addition to this, there is a partnership being explored between HP and the Foundry, where you could potentially be able to approach HP and ask, for example, the Nuke 1 build, and have specific hardware requirements to guarantee compatibility and performance. So now we're going to jump into a demo of Nuke 10 and explore some of these new features and enhancements. In Nuke Studio, we're going to take a look at the new localization system, which is parallel with both Nuke, NukeX, and Nuke Studio. We'll explore the new playback optimization in the timeline, as well as some of the new Nuke Studio soft effects, including blink script, the chroma keyer, and the color correction node. We'll then take a look at the new Smart Paint toolset, which is in NukeX and Nuke Studio, as well as the new Ray Render node, which is available in Standard Nuke, NukeX, and Nuke Studio. Okay, so we're going to first start with looking at the playback and localization improvements to Nuke 10 using this clip here. This is a DPX 10-bit sequence, and we're just going to test, first of all, playing that back at real-time 24 FPS. So I'll just hit F12 to clear my cache there, and you can see without issue we're playing that back. So I'll just reset that cache again and play that straight away up to real-time without any delays there at all. So now what I'm going to do is just pile on a few different soft effects just to see how far we can push this. So I'm putting a mirror there to flop that over. And again, it's still running at 24 frames per second. And I'll put on a grade node here. And in real time, whilst this is playing, I'm just going to just jump on the exposure there and gamma down. And again, it's still staying at 24 frames per second. And we can do some grading here, jumping on the dials without actually any slowdown at all, still in real time. So I'm going to put a color correction node on here, as well as a bit of a burn in, so I can see that on again, still real time. Okay, and now we're going to have a look at the localization setup. So I'm going to turn that on, and the top bar, just going all the way to the right there, is the progress bar. So now this is just giving a visual cue of where this is at. And we now also have more control here. So underneath the cache menu in localization, we have the ability to pause this process, to force always using the network location, or to force update all of the clips or selected clips, as well as clearing that local cache. So this is running as a background task, and it's no longer going to slow you down whilst you're working. Next up, we're going to take a look at one of the new soft effects which has been added to Nuke 10. And this is the chroma keyer. This is available both in the node graph as well as the timeline, and we're going to be demonstrating that with this clip of Jess here. So currently it's a little bit overexposed, so I'm just going to grab a color correction node and just pull down the exposure slightly there. So this is the new node which has been added to Nuke 10. Previously there was only just a standard grade node. So I'm applying this new chroma keyer, and just to note, this was written using the blink script new soft effect node. We can see here that this is basically effectively a stripped out key light node, and it's going to give you the same output. It just has a few less controls to make it a really fast one-click keyer for pre-visualization on the timeline. This isn't generally used for a final key, but for previewing it and testing it, creating a look dev, this is fantastic. So I'm just going to go ahead and pick a color here. And I've got a gray constant, so I can turn that one off and we can preview what that alpha channel looks like. So just a note, this is a green shirt on a background, so we're not going to be worrying about that in the preview of it. That would be something that would be addressed with roto or additional keys in the comp. But you can see here the ability to play back at real time whilst adjusting the key can be really useful. Oftentimes when you're keying, you might find a frame that's working, it's all perfect, but in motion it starts to fall apart. So being able to key in real time is actually does pay, it's quite useful to be able to do that in real time. Okay, so just looking at the hair detail now, just trying to refine that a little bit before we'll jump in and pop a background in here. Okay, so I'm going to disable this gray and I'm going to insert a new background. So this might be you're with a client and there's a temporary background that you want to put in, get approval for what that's going to look like before you take that to comp and do the final key. In this case, again, we can play this back in real time without any problems, adjust the key, move that background around, flip it around, and we're also using the new the track blending feature, which is later in a later version of Nuke 9 this came out, and it's signified by the blue here. And that basically respects the alpha channel in any track or any clip and will pre-mult that down. So I've put a background behind that and now also just an image floating on top to again demonstrate that track blending. Moving on, we're now going to have a look at the new Smart Paint toolset, which is a new feature in Nuke 10. And we're going to do this with this footage here. Again, this is the same 2K 10-bit DPX sequence of head turning from one side to the other side. And there's going to be multiple examples of this. This is just the first very basic one to show you how this kind of deforms paint to a surface. And I'm doing that now with the checkerboard, which I've rendered out. So I'll just buffer this. And you can see about midway through the sequence, so this is a sequence from 1001 to 1200, and in the middle there at 1100, you can see with the frame that I've set as a reference for this projection around about here. So as the head moves, it's the checkerboard there's sticking quite well to the surface. There's a little bit of a hiccup on the chin, but it's actually the actor's movement of the chin is a bit of a tweak in there, so it's actually correct. It picks up on that small detail. So we're going to use that to warp a piece of tattoo across the surface of the face here. So I've just applied a very, very basic kind of pattern to the face. And as the head turns, we can see it actually respects and warps this as needed based on the motion in the plate. So as it comes around, that too gets occluded correctly and warps into place. In this next example, we're going to have a look at the Smart Paint system with a different plate. So this is, again, it's a 2K plate of DPX of this lady doing some yoga on the edge of a cliff. And specifically, we're going to be looking at the complex motion here in the shirt flapping in the wind and all the different wrinkles going on there. So the first thing we're going to do is to kind of analyze some vectors of that. We're going to take some sort of plate and overlay that. This could be an example of potentially some flapping cloth like this, and we can imagine that there are it's like a harness on top of her that would need to be painted out and patched. So this is the motion vector that has been generated from the original plate, which we're going to use to deform a patch across that surface. So I'm just jumping into the node graph here. Again, with Nuke Studio, you can have both the node graph and the timeline open, and I like to be able to jump between them both. But you can always just use your shortcuts to jump into a compositing workspace as I have done here. So we've got our read node, and below that we've got our smart vector node, which is going to be generating those vectors, and this is the output of that smart vector. So we're going to have a closer look at this node. It's quite basic. All we're doing is specifying an EXR sequence to write this motion vector data out to. We specify a range for that, so it could be the full range by default, as well as choosing the vector detail. So this is kind of the density of the motion vectors. By default, it's 0.3, but I've cranked this up all the way to 1. And the higher this value, so if you're at 1, it's going to take a longer time to compute, but this is an executable node, so you will be able to actually render this on a farm. Once that's generated, you can actually disconnect that from the source because it's basically effectively a read node now, reading that motion vector detail. From there, I'm just copying in a bounding box that I've generated and plugging that into the next node here, which is the Smart Distort. And all I have is just a patch here, and it's just one single image with an alpha. Looking at the properties of the Smart Distort node, I've set the reference frame to which frame I would like to set as the kind of effectively the middle point in my case. The frame distance again is quite important, so we'll have a look at that in a moment in a practical example. We can choose our output, and we can either choose our warped output or we can generate an ST map. And we can also include a mask channel. So if your patch has an alpha channel, in this case I do, then you definitely want to specify that because it effectively is using it as a bounding box to only calculate that area. So my previous bounding box there was relatively unnecessary, but just for that little bit of processing power, it sped me up a little bit there. So I've got this at 84, and this is a representation of a patch, for example, that we want to overlay over the top and match that motion. So if I hit play on this, we can see it's going through that Smart Distort node and warping along. So we're going to have a closer look at the frame distance and and what effect that has on the distortion output. So we've got our frame distance here from 0 all the way up to 6. And you'll notice that when we jump in here and have a look at the lower values, we're going to get some really poor results and streaking off a number of different ways, left and right. Just be aware that to get the end result here, if we're starting at frame 1100 in the middle of this and we're going back one frame to 1099, then there's going to be one warp happening. We go back one more frame and there's going to be a warp on a warp, and then a warp on a warp on a warp, etc. So by the time we get all the way to frame 1001, we've actually done 100 warps effectively to get there. So because of this, the longer your clip is, the more prone you are to having undesirable results at the extreme ranges. It's also going to take longer to process per frame the further away you are from that reference. Now, as I go increase my frame distance here, we're actually getting improved results, and it is in the case of the higher the better, is you do have to find the sweet spot for your type of footage. In this case, after generating a contact sheet here and testing that out, I went with number 5 to get a result which I was thinking worked quite well. So this is the result of that. I'm just taking that patch there, the output of that Smart Distort. It's moving with motion from the vectors. I'm then just bringing some of the original plate over that just to get the creases, the dark folds on top of that before moving that, putting this over the original plate. Okay, so just caching that a little bit there and playing that back. And the result is quite good. It deforms to the surface, and in terms of the alternative of manually warping this over time to match the motion, it's just saved a huge amount of time, and in many circumstances this can just be a huge time saver for artists. They can get their shots done and move on to the next one. In this next example, we're going to have a look at using Smart Paint toolset to remove tracking markers from the face. So I've got this 15 frame sequence here, and to do this without Smart Paint, you'd probably be using a combination of trackers and RotoPaint nodes to achieve this. You might need to break that up into several different patches to achieve the end result. So what I'm going to start with is a clean plate, so just taking a single frame of the frame hold there, painting it out very roughly, and just maintaining that alpha channel throughout, because we're going to be using that in a moment. So we're going to do the same thing. We're going to take that Smart Distort node and generate some motion vectors, which we're going to be using to distort that patch and overlay that on the surface. So after we plug in that patch to the Smart Distort node, we have that warping, and we can see here it looks a bit strange because the mouth is opening a little bit matrix style, and that's because it's distorting the entire plate. But we do have an alpha channel embedded in there, so we just need to pre-mult that down and put it over the original plate to have a nice clean result of patching all of the markers off of the face, like this. Okay, so another just very time-saving tool, avoids having to do extra work of more trackers and more individual RotoPaint nodes. You can do a single frame hold, single paint on that, and simply let the Smart Distort node do the work. In this next clip, we have this lady moving from the left of frame into the middle to the right-hand side there, and there's a number of lighting changes as she's moving from the shadows more into the light. We can imagine there may be some sort of tracking marker, or we need to remove a tattoo, or some sort of cleanup required, potentially beautification to track this. Now, if we're doing that manually, it would be probably a combination of RotoPaint and trackers, but then because of the lighting change, we'd have to grade that over time to make that sit. So we're going to use this clip to look at the example of generating an ST map, an inverse ST map from the Smart Distort node. And in this case, I can actually remove the source from there because I'm not actually distorting anything. I'm just generating an ST map which I can use and plug in to distort later on. So I'm taking that to the output, this ST map, the inverse ST map, and plugging it in. And this is what's actually going to do our stabilization of our plate to help us clean this up. So if I play this through, we're getting the character staying exactly where she is, but the lighting changes are having an effect on her. This would allow you to do a live roto paint, and just with some offset or some tracking there to put this into place and not require any further grading to make the paint patches match over time. So that's it for the Smart Paint toolset. I think you can see how and where this would be an opportunity to save a lot of time in production. Okay, so the last thing we're going to demo today is the new Ray Render node, which is in NukeX and Nuke Studio, and this is effectively a replacement for this scanline render in many circumstances. What we're looking at here is a 10-bit DPX sequence, and this is an example of what you might receive from a 3D department. This is not rendered with the new Ray Render node. This is something we're going to use as a basis to exemplify. We've received some 3D, and we just want to generate an extra pass or two to push this 3D a little bit further without having to go back to the 3D department to request that, go through render, etc. So the first thing we're looking at here is a reflection pass, which we've generated with the new Ray Render node. This is just in quite low samples, but we can plug in different HDRIs and very quickly get a new reflection in there. So if the environment's changed or if there's some feedback for the reflection information to change, we can very quickly render that out in Nuke without having to go back to 3D. And again, so we're looking at a ambient occlusion render through this new Ray Render node. It's very nice and clean. It works in the exact same way that you'd expect it to in another 3D package such as Maya. Just have the same controls and the same quality, and it's also quite fast to render. So let's jump into the node graph and have a look at the setup for this scene. So first of all, I've got a number of different HDRI options plugged into a switch, just so that we can very quickly change that based on feedback from a director or a lead, or we can just try different environments and see what that impact has on the reflections in the scene. So that's just mapped onto just a standard sphere plugged into our scene. And then we have an Alembic cached animation file of this RoboDog hooked up to a reflection node, and that's it. So it's just a standard Alembic file, and if we look at that reflection node, we have a couple of controls for that. And you can see this is the 3D scene of the RoboDog itself. Okay, so in the reflection node, if we take a look, we have the reflection color which we can choose from. By default, it's set to 1, as well as the value. We've set it to about 30% at the moment. So that's just plugged into our scene node as normal, and our Ray Render node just takes the place of the old scanline render, the same inputs. Just a note that the version I'm looking at here is an earlier build, and that there's actually a number of enhancements which will be coming to the Ray Render node, both in terms of stability, performance, and as well as control. So just looking at the output there, you can see the reflection renders very quickly, and we can use the alpha there to cut that out and get the final result, which you could then grade or screen on top of our plate to bring that reflection back in. Okay, so I'm just going to plug in the ambient occlusion instead of the reflection pass here and just let that render out. Okay, so this is just a consumer laptop that I'm using to demonstrate this, but it has the exact same controls that we'd expect on the ambient occlusion and generates a nice high quality result. So if we do have a look at those controls, we have samples to control the quality there, the spread, fall off, and a near and far clipping plane. So exactly the sort of controls you'd have in Maya or similar. Okay, generates a really nice clean result, and you can control it to get the exact look that you're after. And again, grade that or multiply it over your plate to get a bit of extra shadowing or cavity detail, especially useful in a matte painting or a 2.5D set extension, just to kind of push that a little bit further, bring a bit more realism to that, or contact shadow, etc. Okay, that's it for the Ray Render node. In summary, the main two features there are the ability to render out reflection and ambient occlusion, plus the motion blur, shadowing, and anti-aliasing have also been improved. The last thing I'll look at is the new Blink script, which is a GPU accelerated soft effect which we can add on to our clip in the timeline. And in this case, I've just made a little Blink script to allow inverting on the timeline that will play back in real time. So this is something that's very easy to do and allows you to customize Nuke Studio to have real-time performance for any custom gizmos that you might require. So I'm just going to run you through this example that I've created. It's very basic and very easy to do, so you don't actually need to have much programming knowledge at all to do this. It's very simple. So I've named this invert jar, and basically I'm going to be writing out DST as a destination. So I'm just going to go ahead and start declaring some variables. I've got two booleans here, so on and off, whether I am inverting my alpha and whether I'm inverting my RGB. And you can see here I have two tick boxes which have been generated as exposed parameters for the user to control in Nuke Studio. So once I've declared those two, I've got a little void define just to set the user-friendly label for that, as well as their initial state. So by default, I'm going to flip the RGB but not the alpha. Then we've got the void process, which is doing all the hard work. And the first line here is DST equals SRC. So I'm just taking the source and putting it into the DST, which is going to be written out as our end result. I've got a very simple if statement, which is just checking that if I do have my RGB checkbox enabled, then it's going to go through the DST 0, 1, and 2, which is red, green, and blue. And for each of those, it's going to say my maximum value, which I've declared as 1, minus my source red pixel value, which will give me the result. So it's basically inverting. So 1 minus, for example, if the red pixel was 0.5, be 1 minus 0.5, and so the invert would be 0.5. It does that for each of those values, and then it goes to the next if statement where it says if the invert alpha checkbox is false, then it's going to go through and make the destination is going to be the maximum value minus the source for the alpha channel. So SRC3 is the alpha. You simply compile that, and you can save this out as a script which can be shared, so you can put that on Nukepedia or find other Blink scripts which have been written, download those and load your Nuke script. And then you have your parameters which you can access at the user level to quickly turn that on and off. And you can see because this is a Blink script, it's running on the GPU, it doesn't have to compute, and you can just turn it on and off or make some adjustments for it, play it back in real time. So again, I can turn that on between our RGB and our alpha. It's very easy to do, very easy to set up without any scripting knowledge at all. There are a number of great examples in the Foundry help section for Blink script, and I recommend checking that out when you are getting into Blink script. So we're going to look at one more example here, and it's going to run you through the code for this one. This is just simply a constant generator. By default, you can actually create a constant on the timeline. I'm sure that will change in the future, but this is an example of if you need to do something which isn't actually currently available in real time, then you can just write something very simple to do that yourself. So I'm just defining a number of values here, red, green, blue, alpha, and a brightness value. And then in the process, I'm just saying my red pixel is whatever I specify in my red parameter times my brightness, which is a user exposed knob which we can change. So it's very basic, and the interface is very primitive, but you can see I can just very easily there just change the red, green, blue values to create whatever constant it is that you require. And you can also just change the alpha value to if you just need to make an overall change to that. So that's it for the demo. I recommend looking into the Blink script. It is new to Nuke Studio, but it's been around in Nuke for a while, and it definitely empowers you to create some really nice real-time effects. So to sum up, Nuke 10 is all about just sort of stability, reliability, and a couple of new time-saving tools to help artists get them onto the creative work. For future developments of Nuke 10, the VR toolset's going to be coming out at some point during the lifespan of Nuke 10. And one of the big things that is being pushed is a continued commitment to the community and having interaction between production and the Foundry itself. Part of that is going to be the continued alpha and beta testing programs. The beta testings are public access, so anyone who has a valid maintenance of Nuke can get the latest beta when they're released. And as well as that, we're having longer alpha testing periods to ensure that by the time it hits the final release and comes out to the public as a full final version, that the stability is there and all of those things have been tested thoroughly. It's going to be great to see what people come up with for the Blink script that can be facilitated now in the real-time playback through the Nuke Studio timeline. And there is a strong desire to see more feature requests entered, any bug issues, etc. to be submitted to support@thefoundry.co.uk. So if you do have consistent crashes, or if you do have a request for a specific feature, definitely submit that to the Foundry. And if you have a crash, you get the crash screen up, submitting the crash log is really vital to removing any issues which might be there. And the best thing you could do is to send the script, example script of an error, along with a piece of footage, and ideally even a screen cap if it's 10-15 seconds demonstrating the problem, and sending that to support@thefoundry.co.uk. That allows them to very rapidly see the issue, replicate that, and remove any problems which might exist in the software. So if you have a current maintenance of Nuke, you are able to now download the beta from thefoundry.co.uk/products/nuke/beta/10. I hope you found this an informative look into the new features and enhancements coming to Nuke 10. It is expected that the full release will be coming by early to mid 2016, and anyone on current valid maintenance will be able to upgrade without any additional cost. Nuke 10 is a huge step forward in terms of performance and reliability. I think you'll definitely find the upgrade worthwhile. Thanks for your time.